All right, history of the Raspberry Pi Pico. How many of you remember in 2011 when the Raspberry Pi Pico was announced? It was in QST magazine. It was in the what they used to call the hints and keep or strays back in the days. Strays was an expression in QST for oddball news, like a stray cat. They don't call it strays anymore, but it was in this little what used to be the strays area. Raspberry Pi Foundation introduces $25 computer. And you can see a picture of it, and I think I got one in my bag. You can see. I'll dig out and let you see afterwards. But it's about this big. And it was the original version was $35, $25 without an Ethernet connector. Wireless had not caught on really big back then, but that was quite a groundbreaker. I mean, the average PC back then, if you wanted something, was $100, $200. But the idea behind the original Raspberry Pi, it used a processor by the company named Broadcom. The founder, Eben Upton, you can watch the videos on YouTube on how he came up with the concept of the Raspberry Pi. He wanted something that kids, teenagers, and elementary school children could experiment with and not bother mom and dad's computer. They could take a television, an HDMI television, a mouse, and a keyboard, and an SD card for the operating system. That's where the SD card slot, you can't see it in that picture. It's under the underside, and that holds your operating system. Yeah, I see you got yours. Hold it up. You can hold it, Raspberry Pi. There it is. And I'll show it here. I'll show it right here. This is with the optional case you can buy for it. She's got the fan in it too, which is really neat. You got the little CPU fan. And you can see there. Now, and there's the end of what it looks like. Who would ever thought a computer for $35? And so this began the technology climb. In 2015, they were not to be outdone. They did the Raspberry Pi Zero. It was literally this big. The ZBitX radio you will see this afternoon runs on that. It is a small version of the original Raspberry Pi in a small form factor, about 2 square inches. It's tiny.
Yeah, 2 postage stamps.
2 postage stamps, 160 milliamps of current is all it draws. The Pi draws about, probably the newer ones probably run a little, probably 1 amp of current, maybe a little bit over. The original one drew 700 milliamps of current. But this one only 160, and the price, $5. They advertised in the Magpie magazine, which the Raspberry Pi Foundation helped it, and you can get it online free of charge. In the physical print issue, they actually had a Raspberry Pi Zero in the copy of the issue when you got it. And so what some people were doing, they were going buying all the magazines up, putting them on eBay and selling them for 2 to 3 times that amount at the time when this was going on. There is the specifications. You'll see it. If you download the slides, you can see it carefully. They have an ARM Cortex A7 processor. These are smartphone processors. They are what's called a RISC architecture, reduced instruction set computer, or ISC, because the processor in your PC has a complete instruction set, but it takes more silicon to implement it. A reduced instruction set, they discovered that more was not better. They realized, hey, wait a minute, we have less instructions, that's less silicon we got to implement, but we could do more stuff with that, and it takes less power. Your smartphone today was made possible by RISC type processors like the ARM Cortex series. And the Raspberry Pi 5 takes an A72, it's an A53 in the Raspberry Pi 4. A lot of smartphones use that processor in days gone by. And that's why it's such a powerful device. And they get about every 2 or 3 years, they come out with a new Pi. What's going to be interesting, what's Pi 6 going to be? Now here's where we get into Raspberry Pi Pico. You can see the pictures there on the screen. The Raspberry Pi Foundation, not to be outdone, they introduced the RP2040 microcontroller. It was their first in-house microcontroller. Now previously the Raspberry Pi Foundation that Eben Upton started used Broadcom processors in the original Pi. They developed their own silicon, their own architecture, and probably Broadcom actually makes the chip, would be my suspicion. But they did their own processor. Now, that was the Raspberry Pi's Foundation's first foray into their own microcontroller. And in January, they also announced not only the main processor, they announced the Raspberry Pi Pico, the first one, in January of 2021. It was produced in 4 versions, and the price, just like the Raspberry Pi Zero, $5. Can't you buy a sandwich at McDonald's for that anymore? You can see the 4 versions there, the original Pi Pico, the Pi H. The only difference is there's a little 3-pin header on there for JTAG, which is a debugging in circuit. And on the right are the wireless versions. Notice that little silver metallic area, that's your wireless transceiver. There's a shield over it. That's a shield over to shield out stray RF. And so that's the only difference. It's got a wireless transceiver on it. And notice again, the shield on there tells you it's a wireless transceiver. It's probably got a microcontroller and some other RF circuitry under that shield. That's the only difference. And not to be outdone, they introduced about a year and a half ago the Raspberry Pi 2 with the RP2350 processor as its main processor. You can see the new version is a little, but notice it says Pico 2 on the board. And that's significant. When you develop with the Raspberry Pi Pico and the software, you got to tell the Python environment which one you're using, whether it's the original Pi or Pico 2. Okay, let's look over the specifications now. There's the original 2040 and the Raspberry Pi 1. It had an ARM Cortex M0, and the speed was 133 megahertz. You say that's slow. In the PC world, that would be true. But in an embedded system, that's okay. Because you're doing embedded applications. Now, the chip itself has no RAM on it. When you put it into a project, you got to supply external memory. On the Pi Pico board, the memory is supplied. That's another one of the chips on there, is your RAM, which is 264 kilobytes. You say that's small. For an embedded system that has a minimal screen or not that much graphics, it's plenty of memory. Unlike in a PC that needs a lot of RAM. And it has 2 megabytes of flash RAM, which is for program storage. And for a lot of applications, that's plenty adequate. And I will show you mine here now. And you've got yours, Kay. I know you've got this. Mine's the original. That's the original. I'll take it off here so you can see it. Here we go. You've got one. So that's the original Pi Pico right there. I'm going to try to do a little better job of this without popping it. The static electricity buildup. When you handle it, try to handle it by the ends. Don't touch the bend. Yep, see, Kay's got hers with the headers. Now I buy them with you can buy them on Amazon with or without the headers soldered onto it. I buy them with the headers soldered on. But if you're going to put it into a custom project, you might want to buy it without the headers, depending on what your application's for. And I'll talk about this little board here in a few minutes. Put that back on there. There we go. All right. You can see the specifications there of the Pico. You've got 20 general purpose I/O pins. That's you can make whatever function you want to make out of those pins. And that's 2. And by the way, they're multiplexed. You say, what does multiplex means? That means each pin can have more than one function, depending on how you define it in software. The 2 possible functions will be a UART. That is a serial port, an old-fashioned serial port on a PC. It stands for Universal Asynchronous Receiver and Transmitter. UART is what it's referred to commonly as. That's the old-fashioned and RS2 without the voltage levels. Serial. Well, actually, UART is RS232 levels. It's plus 12 minus 12 volts, if memory serves me rightly, was the original standard. To SPI. Now, SPI is called Serial Peripheral Interface. That is a standard that Motorola developed back in the 90s, I believe, or the late 80s. That's a microcontroller standard. It's very common. It takes 4 pins. Now, and then, of course, I2C was developed by Philips Semiconductor, which is now NXP. That was their standard. It's a 3-wire standard, including ground. Which is superior, SPI or I2C? It depends on the peripheral you're using, what it supports. One has advantages over the other, and it depends on what you're using it for. So one is not clearly superior to the other, they're just simply different. I2C, that's what it's called, I2C, I2C. There should have been a subscript, I guess, there. But and of course, it has general PIO pins that are 8 of them that are 8 pins that are generally programmable. And it's powered, of course, as you saw on yours, through a micro USB port. It's powered right through that, which is really, really nice. You can power it directly on the board if you want to, but they provide power through the USB-C port. as well. And that chart is not well, but in the slides you'll be able to see it better. This is on the Raspberry Pi Foundation's website if you want the big one. You can see each pen there. Notice it has different colors depending on what functions you define. Some are single usage, some have two usages, some 3 and 4, depending on, again, how you set it up with the software. That's what determines what. And the 2 at the top right, I believe, are power and ground. I can't see it too well. There's ground pins throughout. You can see on the bottom the JTAG connector. That is for in-circuit serial debugging while it's actually in-circuit, which is very common in microcontrollers today. There's the new Pi 2. Notice that compared, we'll have a chart here showing in a moment, it's got twice the memory and twice the program memory. The Pi 2 was a big step up, but the same form factor. But it's got a little bit different processor. It's an ARM Cortex M33. I think the next slide, and there you are. It has the same number of ports on it though, but it's just that the memory, RAM, and program memory is twice the size. That's the big difference between the Raspberry Pi Pico and the Pico 2. All right, any questions so far? And not, we'll move on. All right. Looking at my clock here. Getting started with a Raspberry Pi Pico is easier than you might think. It's not as difficult. And the cost of getting started is very inexpensive. You could spend a little of $20 to $25 and have a reasonable setup to get started with your own experimenting. And you can buy parts from anywhere. I bought all mine on Amazon. I bet it. It's convenient. It comes to my front door and I don't have to go chasing for it. Okay, well, a good way to get started is a Raspberry Pi Pico like Kay has. And I would recommend, if you're going to start, buy it with the headers on it, with them already pre-soldered. Now you can go through and buy it without them. Some of you can buy it where the headers are in the package and you solder your own. But you probably want to buy it if you're starting out and haven't soldered before, buy it with the headers on it. Well, the beauty of this is, you say that package looks familiar. It is. It is the same size as a 40-pin dual inline package IC. A lot of microprocessors in the 70s were in this package. They were in this form factor.
Darrell.
A lot of them. Yeah, go ahead, Mike.
What's handy with the headers on them is that it'll plug into the solderless breadboards.
Just like this, you can plug it in right here. That's a good point. You can see right there. And I didn't seat it all the way because I want to pull it out, just being careful. And notice, now I'll show this board in a few minutes. It's got headers on here for you to plug the board in. You still got your breadboard. I'll show that here in a few minutes.
Yeah, she's got a solderless breadboard.
And I see Kay has got one. She is well prepared. So.
She's got the whole package.
Ooh, aren't you special? Kay, pass your stuff around. There we go. Okay. And a breadboard and a Windows or Mac computer. I've tried it on both platforms. It works equal. So if you're a Mac user, you're in luck. And now what their preferred editor is called Thonny. You can download it. They have Windows and Mac versions of it. And in the slides online, you download it. The hyperlink is active. It'll take you right to the website. And now there is View Editor. I have tried that one. I've not completely figured it out yet. That's another one that will run it. And another one, the actual Visual Studio Code that Microsoft does now supports the Raspberry Pi Pico, but I have yet to play with it and figure out how to use it. But Thonny is a good way to start. That's the official Raspberry Pi Foundation preferred method of starting. But feel free to try it and try the others. And if you let me know, we'll get your information in at the end. And if you have luck, let me know how you do with that. Now there's 2 Python interpreters. Now Python is an interpreted language, unlike C++ that is a compiled language. It actually runs on the fly and interprets as it's running, like BASIC does. But Python today, in the Raspberry Pi world and in the Pi Pico, is a preferred method of development. Used to be, in days gone by with microcontrollers, the real hardcore guys coded in assembly or in binary directly. Most of them were assembly back in the days gone by. But today, now that the compilers have gotten to be so good and the interpreters, like Python has become so good unless you're doing like critical timing applications or something, you write it all in Python or C++ now. And C++ will compile down into machine code and it works wonderfully. But Python actually runs, it interprets as it runs. So when you load it into the Raspberry Pi, you load a Python environment. And you have 2 choices. CircuitPython or MicroPython. MicroPython is the official one for from the Raspberry Pi Foundation. MicroPython or the CircuitPython was developed by Adafruit. I think they were behind that one. It has some different, you see, their Python version has different header files in it that you can get that's not available in MicroPython and vice versa. And when you feel free to experiment with both. It's easy to change. It is super easy to change. And there you are. Now that's the board I put in there. I bought this one on Amazon. I think it was 15 bucks or so. SB components. This is it right here, but it's in the slides. It comes with a few headers in the box. Place for your Raspberry Pi Pico. It does a set of headers right here. Go into some switches down here, LEDs here. And of course, you can use the breadboard as well. It's all handy convenient in one package. That's a neat, and there's another one that I didn't have a chance to put in the software, on the slides, that actually has a little LCD screen. It comes with it on the board. That's a new one I got to purchase from Amazon. It's about 30 bucks. And I didn't have a chance to put it in the slide presentation. The link is in the slides when you download them. You can go right to it. Hopefully, that's the only link I didn't check. But I do believe they're still selling it. All right. That's a little board there I've got also with me that y'all can look at afterwards. That was the first one I bought. It's a PICO development board. It has headers on it. You can plug jumpers into an external breadboard development socket. You use one externally. That was the first one that I found, and the link is there in the slide presentation. Here's a sample Raspberry Pi program. Here we go. There's a sample code. That's the Hello World program. Now, import machine, import time, that's two header files it has to import in order for the functions to work, as they call them C++. Then in Java, they're methods. That's the difference, but the same thing. From machine import pin, that imports that, let's see, from the machine header, it imports that object. That's the word I was looking for, that object. And then from the time header file, it imports the sleep object. Remember, in C++ programming, an object is a module of code. You could change it internally and it don't affect the outside. So in other words, objects in C++ and objects in Python are reusable. You can use them in different places of code and you don't have to write them again. Use somebody else's work. That's a neat thing about C++ and Python. And the next command, myLED, they're setting that LED pin, the one that's built in on the board, they're setting it to be output. So the LED, because that LED is tied to the outlet to that port pin. I forget which pin it is on the Raspberry Pi Pico. I can't recall it in a moment. But it gives it the variable myLED. So in other words, as far as Python's concerned, myLED is that LED on that port pin and it's an output. That's what that command defines. While true, that's the main method or object or whatever you want to call it. While true, it's never false. So it runs in a loop. It turns on by LED with a value of 1. That means it turns it high and turns the LED on. Sleep 0.5, that particular object is a time delay of a half second. It's in seconds. Then it turns the LED off. My LED value is 0 for half second. So the LED wants to do this. Blinking. And it runs forever until you stop it. That is like the Hello World. You remember, if you programmed in days gone by, you would say print Hello World and make Hello World print on the screen. That's what this does. It's the equivalent of the Hello World program. Okay, I'm going to try to demonstrate this if I can. Well, let's watch the YouTube video. It's in there, so let's go ahead and bring it up. Hopefully this will work. I haven't had a chance to try it in here, so we'll see. Why am I not surprised? Blocked. So much for that great idea. Okay, here's some resources, and then we'll come back probably about probably 1 p.m. this afternoon. I'll do some hands-on with y'all, and we'll try to put the camera over there so we can record it. Here's some resources. They're in the slides for you that will help you. Raspberry Pi Pico manufacturer's website, and there's an excellent getting started tutorial on there as well. That's really, really good. But this is my favorite coming up. Let's see, I'm sorry. This is a book online at archive.org you can actually download. I checked these links Just 2 days ago, they're still active. And also a beginner's guide for the Raspberry Pi Pico at Seed Studio. They're another vendor for it, and they did an excellent guide as well. Now, what I recommend is this series right here. On YouTube, Paul McWhorter, he's known as the tech boy and the Bible boy. And a lot of people find his tech videos from his Bible study series. He does both. And his series on the Raspberry Pi Pico W is over 100 lessons. He's done another 100 lesson series on the original Raspberry Pi. And he's done it on the Arduino. He has several series. They're very high quality. The video and his workbench are all mixed into the video. You can actually see it. They're very, very well done. And his favorite expression is black coffee with no sweetener, no creamer. He always says that. But it's over, I think, 106 lessons. It's very, very detailed. They're about 20 minutes each. It's an excellent series. And there is my contact information. So if anybody has any questions, I'll take them.
I want to pause video.
Have you seen his? Aren't they good?
Yes.
It is probably the best that I have found.
He is my friend, neighbor.
I didn't know he lived in Manatee County.
In Texas.
Oh, okay.
El Dorado.
Yeah, because he does have the palm trees out back. You can see him behind there in his
But
background.
he's in South Africa.
Oh, really? Explains why the palm trees. But yeah, Paul is a very dynamic individual. He's always very entertaining to watch. So, but, well, does anybody else have any questions?